Good morning, everybody. Mrs. Dixon here, and I want to go through a PowerPoint today on ecology. So let's take a look. And so I asked you to think about the one thing that's not recycled here on Earth, and if you hadn't guessed it, it's energy. So at some point you can take a look at this video and look at all the different ecosystems around the Earth and the different biomes and look for the different producers who are doing photosynthesis. Today we're going to talk about the transfer of energy, food chains, food webs, and energy pyramids. And these are three different models that we use to look at the transfer of energy. So the sun is the source of all energy. It powers all of our biogeochemical cycles, from the water cycle to the carbon cycle to the hydrogen, oxygen, nitrogen cycles. And that's because it's an atomic furnace. It's where nuclear fusion is taking place. So the sun is extremely hot, and we know this because we can feel it every day when we go outside. What's happening on the sun's surface is a process called nuclear fusion. You may have heard of nuclear fission before. This is the process of taking an atom and dividing it into two, and it creates a tremendous amount of energy. This is the energy you'd find in a nuclear power plant, or you'd find in an atomic bomb. Nuclear fusion creates even more energy. So in this process, we're going to take two atoms and combine them into one. So as you can see here, we have 600 million tons of hydrogen being converted into 596 million tons of helium. And as a result, we get 4 million tons of converted mass to energy every second on the surface of the sun. And that's a lot of energy. So how do we harness that energy? One model we use to represent this is called an energy pyramid. This shows the transfer of energy from producers to top consumers. And it starts with sunlight. The sunlight is the source of the energy, and the producers are the only ones that can do photosynthesis in order to convert this energy, this light energy or radiant energy, into a usable form of glucose. And we can see that the producers have the largest block at the bottom of our energy pyramid. This is critical because they have not only the most energy, but they're going to provide all the energy for all the subsequent layers. So a primary consumer, which would be anything consuming a producer, which could be a herbivore or it could be an omnivore eating a plant, they're going to receive their energy from the producers. The producers, however, need to use some of their energy for growth and reproduction. So only 10% of the energy will be pushed on to the next level of the primary consumers. Likewise, the primary consumers use some of their energy for growth, reproduction, maintaining body temperature, and only 10% will move on to the secondary consumers. The secondary consumers would be organisms that are eating primary consumers. So this could be omnivores eating meat, or it could be carnivores eating meat. Only 10% of that energy will move on to the tertiary consumers, or the apex predators. Finally, the last remaining part of energy moves on to the decomposers, and they use it for their life processes. This isn't the only thing that we can learn from an energy pyramid. An energy pyramid also represents the amount of biomass. So there needs to be more mass of producers to support the numbers of primary consumers and subsequent numbers of secondary and tertiary consumers. So there's only 10% of the biomass at the next level. So if producers have 10,000 units, the primary consumers will only have 1,000 units, and the secondary consumers would have 100, and the tertiary consumers would have 10. So let's talk about all the roles that these organisms play. Producers are the autotrophs. Autotrophs are organisms that make their own food, and they do this through photosynthesis. So this would include all plants and some photosynthetic bacteria. It's important to note that this does not include mushrooms, no fungus. This is a common misconception for students. Mushrooms are actually decomposers. They don't have any chloroplasts, they don't do photosynthesis, and they don't need sunlight. Consumers are heterotrophs. They must consume food in order to obtain energy. This will include the herbivores, omnivores, carnivores, saprophytes, which are decomposers, and scavengers and parasites. So let's go through all those. An herbivore is an organism that eats only plants for food energy. This includes deer, cow, and sheep. This does not include, for instance, though, humans, which are omnivores, who choose to eat only plants. you're still an omnivore. Just because you're a vegetarian or a vegan, that doesn't change what you are. An omnivore is an organism that eats both plants and animals for food energy. This includes bears, pigs, dogs, and humans. Carnivores consume meat only. They do not rely on plant life for food energy. This would include cats, Tyrannosaurus rexes, hawks, and crocodiles. Parasites are organisms that parasitize other organisms for food energy. So they feed off other organisms, compromising them or harming them in some way. This would include tapeworms, ticks, and fleas. Scavengers are organisms that eat dead organisms for food energy. So this is different than decomposers because they're not breaking them down, but rather consuming them. So I call them my roadkill warriors because they're commonly found along the roadside eating dead organisms. This would include turkey vultures, raccoons, hyenas, and possum. The last group that I want to talk about are the decomposers, and these are the recyclers. These are really critical. They break down materials and return nutrients to the soil. So they're going to be the ones responsible for returning the nitrogen, hydrogen, oxygen, carbon back to the earth once an organism dies. And the one thing that they don't recycle, the very one thing that they don't recycle, is energy. Everything else goes back to the earth except for the energy. And this would include bacteria and mushrooms. So one other model we use to show the transfer of energy is a food chain. A food chain shows the movement of energy from one organism to the next. It must always start with a producer, like grass, and end in a decomposer, like bacteria or fungi. So what it shows is the movement of energy from one organism to the next. The arrows show the direction of energy flow, so the energy is going from the grass to the cow, from the cow to the human, and from the human to the bacteria. Please always use words and not pictures because it's easy to tell what you're trying to represent when you use a word. Sometimes it's more difficult with pictures. And each organism should only appear once. We know that there's not just one path of energy flow in any ecosystem, and this is why we have a more appropriate model for showing ecosystems called a food web. A food web is more realistic. It has many, many food chains. For instance, we have one here from aquatic plants to the smelt, to the egret, to the heron. That's one food chain. Or from the terrestrial plants to the snail, to the grasshopper, to the rat, to the owl. That's a second food chain. So there's many food chains within this one food web, and it includes all the feeding relationships. The advantage to food webs is then we can start drawing conclusions about what would happen if one organism was removed for some reason. So let's say that this was in an area that was around humans, and they didn't like the fact that there were lots of rats around, so they started trapping the rats and removing them from the ecosystem. This decline in population may cause the hawk and owl population, because they're consumers of the rat, to decrease in population. And it would most definitely decrease the harvest mouse, the vole, and shrew populations because the hawk would be eating more of them. This is also true for the sparrow, the mallard, and the sandpiper because the owl would be eating more of them. When we remove organisms that are closer to the base or closer to the producers, like a snail, it has a larger effect. If the snail population were to go down because maybe we wanted less snails in this aquatic ecosystem, it would affect the amount of grasshoppers, shrew, rats, sparrows, mallards, etc., and all the feeding relationships in this area. So we're going to practice some food chains and food webs this week, and this gives us a great insight into the niche and the role of each of these organisms, especially with how they transfer energy. So that's all for the PowerPoint today. Remember, we're going to be going through the Group B vocab on Friday. So have a great rest of today and tomorrow, and I'll see you on Friday.